Yeah. Hello, everyone. Thank you for having me here today. So in the next 15 minutes, I will do a brief recap, not too long, on what oracles are and what is the approach that Oraclize is following, what we have building during the last 2.5 years, and what are the plans for the future, and some use cases in the financial sector. So first of all, I guess most of the people in the room know what an oracle is, but the problem is that basically integrating data coming from a context which is different from the blockchain into a blockchain application is quite complicated for technical reasons. One problem is that most of the times the provider of the data doesn't have an integration with the blockchain or simply doesn't care. So reaching out to existing web APIs or external services providing the data, distributing the data, is not trivial because of the architecture, because of decentralized architecture, basically. So what we invented is, well, we didn't really invent, of course, the Oracle model, because the Oracle model in the blockchain sense is just an identity on the blockchain. So think of a simple account sending data. So this is trivial, right? If you're a developer, you can set up an Oracle. Pushing data to the blockchain is probably, I don't know, 5 minutes. So this is not what we do. What we try doing is providing data to the blockchain in a way that you don't have to trust us. So when you send data to the blockchain, of course, you can verify who is the sender. So you can know that a given account that maybe is owned by Thomson Reuters is sending data to the blockchain. In the case of Thomson Reuters, as you will hear later, there is no really open trust line other than the data provider itself, which is a trust line you have every time. So if you want to use financial data from Thomson Reuters, you have to trust Thomson Reuters, right? But since the owner of the data is matching with the party sending the data to the blockchain, then there is no open trust line. But in the case of Oraclize, we want to send data to the blockchain from existing web APIs of third parties. So it's not the same party, the provider of the data, and the one sending it to the blockchain. So we need to prove we are not tampering with the data. And we do it with authenticity proofs. So the authenticity proofs is this concept of trying to prove to our clients, to who receives the data, that the data is indeed authentic. It's not of good quality, it's not data which is necessarily correct. It's just the same data that was provided by the third party, by the web API, for example. So of course, you don't want, in a blockchain context, to just trust one web API, or it wouldn't make much sense to use a blockchain, really. But what is interesting is that thanks to the way the system is agnostic, you can use any existing web API. So let's say you want a price feed. You don't need to get the price feed from one party. You can get it from like 10 different parties and use Oraclize to fetch data from each of them, verifying that it's authentic as reported by those parties. We use different techniques. I don't go into details because we just have 15 minutes, but basically we use trusted computing techniques and other sandboxing techniques to prove that the data fetching is not malicious, so that it's done properly and that we are not tampering with the data. So this slide is quite technical, but the idea is that because of the way those techniques work, you are always trusting somebody, really. So even when Oraclize sends data to the blockchain, we provide the result of a third party and the authenticity proof. But the authenticity proof is not a proof that the data is 100% correct. It's just a proof of the fact that according to the trusted computing device, which is this secure chip which you cannot really tamper with, the chip itself claims that the execution was correct. So this is the way the communication is secured. But the chip is not, some magic ideal device. It's something which is built by somebody. And this somebody could really have a backdoor or have a system to basically make the system unsecure. So this is why we are using different techniques and we are using different devices so that, you can still tamper with the data, but for it to happen, you will need all the biggest providers on the planet to be tampering, well, to have malicious backdoors and be leveraging it at the same time in a synchronized way, which is quite unlikely. So to make an example, let's say you want to fetch some data from some weather APIs because you want to know what's the temperature in Zug in this very moment. What you can do is using Oraclize and the Oraclize service to fetch the data, securing the data fetching with several techniques, all the techniques you see here. So basically, we use TLS Notary, Qualcomm, Intel, the Ledger Nano STE, which probably some of you are familiar with, and other techniques, so that the claim on the temperature is backed by all the companies backing those technologies. So they are backed by a claim coming from Qualcomm, from Google, from Amazon, from Intel, and so on. So this is quite safe. And the interesting part is that it's not a claim coming from Oraclize itself, because Oraclize is a small startup of 10 people. You don't want probably to have several millions depending on our claim unbacked. So here we are shifting the trust away from us to more reputable players in a way that is safer. So this is a very simple example code in Solidity. I don't want you to dive into it, but this is similar to the one we have integrated with Melonport a while ago, 7 months ago or something like that. There is a URL, if you're interested, where you can check out the Melonport module. It's simply fetching the data from different providers. Here in the example code, we just fetch the price of heaters in US dollars from CryptoCompare, but you can get it from any data feed, really. And as you can see, Oraclize is just, well, it can be used in different ways, but in Ethereum, you just call the Oraclize query from a Solidity smart contract, and Oraclize sends back a transaction with the result and with the authenticity proof. Something else that we have seen is quite used in the financial sector, especially on private chains so far, is the auditable off-chain computation, which does leverage the same concept I've explained, so the sandboxing and proving via security devices that a given process is secure. But it is using it not to fetch data, but to do something much more generic, which is executing a piece of code. So, of course, this is what we get from smart contracts. So you can do it directly on the blockchain if you don't want a single party to execute a piece of code on their own servers because you don't trust their outcome. But in some cases, you want the DApp, you want the smart contracts to be able to do some complex calculations which cannot be done in the smart contract itself for different reasons. Because maybe it's too expensive gas-wise, or maybe because it's not possible to have the primitives you need, the financial primitives you need, or the libraries you need. So in that case, you can execute like the pricing engine of a derivative or whatever you like in an off-chain context, which is probably fully locked down, and you can just get the result and prove to the smart contract that the result executed off-chain is safe. I will show you some projects that are being done on Oraclize. So on the mainnet, it's mostly gambling games. So if you look on the Ethereum mainnet, most transactions are from exchanges, from Ether Delta, so exchanges again, ENS, and gambling games. That's it. There is really nothing else other than really few transactions that don't account for much. And this is obvious because of regulation and of the fact that many interesting dApps are not ready for production yet, or because maybe some people don't feel confident to move from testnet to production yet, to the mainnet. Or maybe because they are using private chains. So in the gambling games, it's being used just to extract random numbers in a provable way and blah, blah. But this is not interesting for the talk today, so I would like to focus on the rest, which is, well, this is a proof of concept that we are working on with the FCA in the UK, with the FCA Sandbox program. This is basically the boring issuance of ERC20 token fiat backed. So Sterling tokens is really nothing new. But the difference here is that this is backed by the regulator, and we are using it with digital identity cards, so that digital identity cards can be used as a wallet. It means that you don't need to, buy a Ledger Nano S or to install the software and keep your private key safe. If maybe you want to buy just, $200 US, really, you end up wasting hours, and there's a lot of complexity for nothing. So the idea here is that you can use something you already have, like the identity card, and use the chip inside the identity card as a wallet. And this is what we integrated with Ethereum in the last year and a half. And we are using it to enable people in the UK to move around Sterling tokens, which can be redeemed to Sterling. Something else which is being used by Oraclize, those are third-party projects, is, derivatives on the blockchains. So there are some banks that are investigating and using mostly the off-chain auditable computation I mentioned to do some data fetching, but not much because, Thomson Reuters. But above all, they are using it for delegating complex financial computations, which they cannot do on the blockchain, but maybe they would like to. Something else which is quite interesting, given the agenda of today, of the events today, is decentralized exchange, in the sense that one problem of decentralized exchange is order matching. And there are different approaches, of course, to do order matching. Doing it on-chain is nightmare, so you typically do it off-chain. There are some companies like Aidu, which is a project based here in Switzerland, by the way. And they are using Oraclize, the computation data source again, to prove that basically the off-chain order matching is being executed in a legit way, and basically it's not doing front running by the exchange, is not doing any censorship, and so on. Of course, there is nothing wrong that could happen with the order matching in theory, because the smart contract can verify it. But if the order matching is done in a centralized way, the operator can always try to take advantage and decide which order should match which other one. And decide how to prioritize orders, basically. So this integration they are doing is leveraging the authenticity proofs to show that they are not doing it and that they are behaving honestly. There are several Oracle services similar to ours, general purpose, that came up recently or in the last year and a half. So far, they use different approaches. So Microsoft is using an approach which is similar to ours. There is Chainlink, which is using some of the technologies we use. But so far, at least on the mainnet, Oraclize is the most widely used because it's out there since 2015. So we have sent on the main chain 300,000 queries so far. And in the last few days, we sent on average around from 3,000 to 5,000 per day to smart contracts that call for data, basically. And we have blockchain integrations with, you see, from public chain, private chains, pretty much everything. We are working a lot on authenticity proofs to enable their on-chain verification, which is something we present at DevCon 3 in a couple of weeks. And we have other new developments and things that will be coming out in the next few months. Yeah, that's basically it. If you have any questions, I think we still have a couple of minutes maybe.